Okay, the last part of this activity is to identify the maximum material condition and least material condition for each load-bearing surface. Let's take a look at this. The most material of a hole is when the hole gets smaller. I have more material in my part as the hole gets smaller. I can remember that. MMC for a hole is the smallest one. So here's the one that has a hole. My maximum material condition is when the hole is as small as it can be. Equals 1.355 minus tolerance. Okay, and I'm going to change that back right now because I'm already telling it it's a minus tolerance up there. So I'm going to read this as minus 0.010. This one is plus 0.010. Okay, so let's go through that one again. Here's my one that's an inside diameter. It's got the most material, the maximum material when you start with a diameter and then you make it smaller and smaller and smaller. Okay, so it's the nominal minus that tolerance. That's what I just did. Okay, a spur gear has more material if the tips of the gear get bigger and bigger and bigger and bigger. Maximum material is the nominal plus the tolerance. Maximum material is nominal plus the tolerance equals that plus that. So that's my maximum material condition for each one of those. And so I can see if I get this one put together with this one, what do I have? Equals this minus that 0.025. Well, that's pretty good. Okay, because that's total. Well, I'm getting ahead of myself, so I'm not going to do that just. Okay. Now let's look at the least material condition. For the housing, so we'll have the least material if I start chewing it that way. So the diameter gets bigger. My plus tolerance. It's going to equal that plus tolerance. Okay, and now it goes the other way. Okay, my gear is the least material when I take my gear and subtract the minus tolerance. So this one equals this minus this. Oh, I did the wrong minus. Let me get rid of that. This one equals this minus that tolerance. 1.290. Okay, so that's how you do your MMC and your LMC for the gear and the housing. And I'll leave this on so that you can see what the equations were. But I really suggest you kind of think it through. If you have to do this type of problem on your own, it's good to know. Look at that picture. Okay. When does this part have the most material? It's when that diameter gets smaller and smaller and smaller. When does it have the least material? When that diameter gets bigger and bigger and bigger. And you just have to make sure that you're doing your numbers in that direction. Okay, so there you go. We've now identified the MMC and the LMC for each load-bearing surface, and we've made a table of the values.